Hello everyone. Today I'm going over the extra problems of chapter 5. The first question, which one of the following will produce the highest present value interest factor? Now, if you all remember the formula, we have FV equals PV into 1 plus R to the power T. Therefore, I can write PV as FV divided by 1 plus R to the power minus T. So as you can see, there's a negative relationship between R and PV and between T and PV. So as R increases, PV will decrease. As T increases, PV will decrease. And you can think about it this way. If you are able, if you want, let's say, to buy a house that will cost you $200,000 after 10 years. So if you can earn a higher rate of return, if you can earn more on your investment, this means that you need to invest less money today. You will need a lower present value. Now, in case you want to buy the house that will cost you $200,000 20 years from today instead of 10 years, this means that you can save less money today. You can have a smaller present value. Now, in case you cannot tell, like based on those relationships, what should be the correct answer, you can simply compute the present value interest factor for each one of those 5 different cases. Of course, you will take the future value as $1 and then compute the present value. So now, which one will produce the highest present value interest factor? It's gonna be the one with the lowest R and the lowest T. So in this case, here you have 7% for 5 years, 7% for 7 years, and 7% interest for 10 years. So I can eliminate B and C because A simply has a lower T. They have all the same R. A has, however, a lower T. Now, D and E, they have the same R. However, D has a lower T, so I can eliminate E. Now, between A and D, they have the same T with a different R. I need to choose the one with the lowest R, so I choose A by eliminating D. So the correct answer is A. Now, for example, if you had the following, if let's say here I had also F. So for F, for example, you have 8% interest rate. So R equals 8%. T equals 4. In this case, I cannot directly tell because as you can see, A has a lower R, however, F has a lower T. In such cases, you need to solve. You need to compute PV here. So here I compute PV. I will get an answer. And I compute PV here and I'll get an answer. Then I choose the one that will give me the highest present value interest factor. Number 2 is very similar. So if you look at this formula, FV equals PV into 1 plus R to the power T. In this case, there's a positive relationship between R and FV and between T and FV. So as R increases, FV will increase. As T increases, FV will also increase. So the one that will give me the highest future value interest factor will have the highest R and the highest T. So in this case, I should choose E. 10% interest for 10 years. Now for number 3. What's the present value of $150,000 to be received 10 years from today if the discount rate is 11%? Now, for all of the problems, even if they are straightforward problems, I will try to draw the timeline. In this case, I have the following. I need to find PV of $150,000 to be received after a certain period of time. Mainly 10 years. So after 10 years, I'm gonna receive 150,000. The discount rate R is 11%, and I need to determine in this case PV. How much money should be invested at time t equals 0. In this case, if you are using the formula, PV equals 150,000 divided by 1 plus R 1.11 to the power 10. If you are using the financial calculator, you will have the following. 150,000 is FV, 11 is IY, you will have 10 as N, then this is compute PV. The answer that you should get, whether you use the formula or the financial calculator, 52,827.7. Now, of course, if you are using the calculator, before you solve, you need to make sure that you click on the second function, then clear time value of money in order to delete all of the previous entries. Now for the second problem, Alex invested 10,500 in an account that pays 6% simple interest. As I said before, you will not see simple interest in any later chapter, and you won't see it in any exam. It's gonna only be covered here in the extra problems and maybe in the online assignment. So here, at time t equals 0, Alex invested a present value equals to 10,500. This investment is over a 6 years period. It's for a 4 years period. The interest rate R is equal to 6%. However, this is a simple interest rate. I need to compute FV. FV equals PV into 1 plus R times T. So 10,500 times 1 plus 0.06 times 4, and the answer is $13,020. So this is with the simple interest. As you can see, instead of raising 1 plus R to the power T, like in the compound interest, it's 1 plus R times T. And of course, the compound interest will always yield a much higher future value. Now for number 5, You'd like to give your daughter $75,000 towards her college education 17 years from now. How much money must you set aside today for this purpose if you can earn 8% on your investment? So here, the $75,000, you need to have it after 17 years. This means that the future value is equal to $75,000. This is the amount of money that you will need later on in the future. You need to determine how much money you should invest now, how much money you should set aside today at time t equals 0. So you need to determine the present value PV, given that you can earn an 8% rate of return. R equals 8%. If I'm applying the formula, PV equals FV 75,000 divided by 1 plus R, 1.08, to the power T, 17. If I'm using the formula, I need to make the following entries. After clearing the time value of money, I have 75,000 as FV, 8 as IY, 17 as N, then I compute PV. The answer that you will get is 20,270.17. Now, the answer that you will see on your financial calculator, it's gonna be minus $20,270. And that negative sign only means that this cash flow, this future value is going in the opposite direction of the present value. It doesn't mean that the amount is negative. It doesn't mean that you're going to lose, let's say, $20,000. That this is like a loss. The negative sign only implies the direction of the cash flow. Number 6, 10 years ago, so in year minus 10, Jackson Supply set aside 130,000. So here we have an amount that was invested 10 years ago. In case of a financial emergency, today that account has increased in value to 330,592. So at time t equals 0, I have now 330,592. Now, as you can see, this is PV and this is FV. Because FV is the later amount on a timeline, PV is the earlier amount on that same timeline. So what rate of interest is the firm earning on this money? I need to find R. Now, to find R using the formula, it's gonna be much more complicated. So just to show you quickly, if you are following the formula, mainly you have FV equals PV into 1 plus R to the power T. So you will have 330,592 equals 130,000 into 1 plus R to the power 10. Because here N is equal to 10 years. From year minus 10 till year 0. In this case, R is equal to the following, is equal to 330,592 divided by 130,000 raised to the power 1 over 10 minus 1. The other way to solve is to use the financial calculator. You will have 10 is N, 330,592 is FV, 130,000 is PV. However, if I solve this way, if I click on compute IY without making any adjustment using the financial calculator, I will receive an error because I'm entering the present value and the future value as if they were going in the same direction. So in this case, I need to enter that value with a negative sign to imply that the present value and the future value are going in opposite direction. So when I solve and I compute IY, I'll get an answer of 9.78%. Now I move to problem number 7. Assume the total cost of a college education will be $300,000 when your child enters college in 16 years. So after 16 years, I need an amount of 300,000. You presently have 75,561. So this is at time t equals 0. So this is PV and this is FV. What rate of interest must you earn on your investment to cover the cost of your child's college education? So it's the same problem as number 6. I have n is equal to 16. I need to compute r. In this case, minus 75,561, this is PV. 300,000 is FV. 16 is N. I compute IY and the answer is 9%. So all of the problems so far are straightforward applications of the time value of money formula that we've learned in chapter 5. Number 8, some time ago, Julie purchased 11 acres of land costing 36,900. So at a certain point in the past, Julie paid 36,900. Today, that land is valued at 214,800. So after a certain period of time, the value of the land is 214,800. This means this is PV and this is FV. How long has she owned this land if the price of the land has been increasing at 6% per year? So now I have R, I need to determine T. In this case, minus 36,900 is PV, 214,800, this is FV. Excuse me, R here is 6%, R equals 6. 6 is IY. Compute N. N in this case is equal to 30.23 years. So Julie did buy this land 30.23 years ago. Now number 9. On your 9th birthday, you received $300, which you invested at 4.5% interest compounded annually. So here, this is at year 9. you've invested $300 at 4.5%. Your investment is now worth $756. So this is FV, this is PV. How old are you today? Now, in order to determine your age today, we need to find N. How many years passed since you were 9 years old? In this case, minus 300, this is PV. 756, this is FV. 4.5, this is IY. And I can solve for N. N in this case is equal to 21 years. However, this is not the final answer, because 21 years is the number of years that passed since you were 9 years ago. Your age today is equal to 9 plus 21. This is equal to 30 years. So you are now 30 years old, because here we have 21 years since you were 9 years old. Number 10, at 8% interest. So if R equals 8%, how long would it take to quadruple your money? Here I don't have FV or PV. However, I know that FV is equal to 4 times PV. The easiest way to solve is to assume that PV is equal to $1. So if PV is equal to 1, FV is equal to 4. So I will have minus 1 is PV, 4 is FV, 8 is IY, compute N, and the answer is 18.01 years. Number 11, you invested $1,400 in an account that pays 5% simple interest. How much more could you have earned over a 20-year period if the interest had compounded annually? So here I need to compute first using simple interest, the future value using simple interest, then I compute the same future value using compound interest, and I find the difference between the two values. So first, with the simple interest, that investment is paying 5% over a 20 years period. PV here is equal to $1,400. Using the formula of simple interest, FV is equal to 1,400 times 1 plus R, 5% times 20. The answer here is $2,800. So using simple interest, your investment will double in value over a period of 20 years. Now, using the compound interest, I have PV is 1,400, 5 is IY, 20 is N, and I compute FV. In this case, FV is equal to 3,714.6. Now, the difference between the two values is equal 3,714.6 minus $2,800. The answer is $914. 12, you just received $225,000 from an insurance settlement. You have decided to set this money aside and invest it for your retirement. So at time t equals 0, you have a PV of $225,000 that you're gonna invest. Currently, your goal is to retire 25 years from today. So your investment is going to be over a 25 years period. How much more will you have in your account on the day you retire if you can earn an average return of 10.5% rather than just 8%? So in this case, I need to find the future value twice. Once using a rate of return R equals to 8%, and the second time using a rate of return R2 equals to 10.5%. Now, in the first scenario, I have 225,000, this is PV, 25 is N, 8 is IY, I compute FV. The future value in this case is 1,540,906.9. Now, if I can earn 10.5%, those values are still the same. So I have 225,000 as PV, 25 as N. However, now I have 10.5 for IY, and I compute FV. The answer is 2,730,482.9. So as you can see, this additional 2.5%, it had a huge impact on your investment over this 25 years period. So if you can earn this additional 2.5%, you will end up earning an additional 1,189,576. So this is the answer, the difference between the two values. So always the higher the rate of return that you can earn, even if it's by an additional 1 percentage point or 2 percentage points, this will have a very huge impact on the future value of your investment. Number 13, you are depositing $1,500 in a retirement account today. So at time t equals 0, I have PV equals 1,500. You expect to earn an average return of 7.5%. R equals 7.5%. How much additional income will you earn if you leave the money invested for 45 years instead of just 40 years? So here I'm gonna solve with two scenarios. The first one is to invest for a 40 years period. I compute FV1. Then for a 45 years period, I will compute FV2, and then I compute the difference FV2 minus FV1. So with the first scenario, I have 1500 PV, 7.5 IY, 40 N, and I compute FV. In this case, I will have 27,066.36. If I extend my investment period by 5 more years, those values are still the same here. However, here I have 45N. I compute FV, and the answer here is 38,857.25. So now, the difference between those two values, FV2 minus FV1, is equal to 11,790.9. So if you invest over 5 additional years, you're gonna get an additional $11,791. Number 14. Your father invested a lump sum 26 years ago at 4.25% interest. So here we have an investment that was made 26 years ago. So we don't know how much money was invested here. That investment was made at an interest rate R equals to 4.25%. Today he gave you the proceeds of that investment, which totaled 51,480.79. So this is FV. So to find PV, I have 26 is N, 4.25 is IY, 51,480.79, this is FV. I compute PV, and the answer is 17,444.86. Number 15. In 1895, the winner of a competition was paid $150. So this is year 1895. In 2006, the winner's prize was $70,000. So after 111 years, this is year 2006, that same price was now $70,000. What will the winner's price be in 2040 if the price continues increasing at the same rate? So this is year 2040. I need to determine the value of the price, so I need to determine that future value. Now here we are assuming that that price is increasing at a constant rate over time. So in order to find the value in year 2040, the first thing that I need to find is the rate of increase in the value of the price from 1895 till 2006. So I need to determine R over this period. Once I compute that R, I can use it here because in the given I have that the price is increasing at exactly the same rate. So I start by saying 150 minus is PV, 70,000 is FV, 111 is N. 111 is 2006 minus 1895. This is 111 years. I compute IY. IY in this case is equal to 5.6927%. Because in this case, I need this value later on. It's better not to round. It's better to use all of the value that you are getting on your financial calculator to use it in the second step. In the second step, now that same $70,000, this is considered a future value for the 150. However, for the year 2040, this is considered a present value because the $70,000 in year 2006 is at an earlier time relative to the value in year 2040. So now I say that the 70,000 is PV. I have 34 years, which is 2040 minus 2006. 34 is N. I use that same value here, 5.6927 as IY. Then I compute FV, and the value in this case is 459,866. The final problem, problem number 16. When you retire 4 years from now, so you plan on retiring once after 4 years, you want to have 1.2 million. So you want to have a future value of 1.2 million. You think you can earn an average of 12% on your investment. So here R is equal to 12%. To meet your goal, you are trying to decide whether to deposit a lump sum today. So your first option is to invest a certain amount of money at time t equals 0. This will be PV1. Or to wait and deposit a lump sum 2 years from today. Your second option is to make your lump sum investment after 2 years. I will call this PV2. How much more will you have to deposit as a lump sum if you wait for 2 additional years before making the deposit? So now, if you invest at time t equals 0, this means that you're going to invest over a full 40 years period. In this case, N equals 40 years. 40 minus 0. So now I solve. I have 1.2 million is FV. I have 12 is IY. 40 is N. I compute PV. In this case, I'm getting 12,896.16. Now, if I wait 2 additional years before I make my investment, I will need more money. In this case, T equals 2. This means N is gonna be equal to 38 years. Because now if I invest in year 2 till year 40, I will have a 38 years investment period. So now the 1.2 million FV is still the same. the 12% IY is still the same. However, now I have 38N. I compute PV. The answer is 16,176.94. So I will need more money if I want to delay my investment by 2 years. To compute the difference between those two amounts, it's equal to PV2 minus PV1, and that difference is equal to 3,280.78.